Okay, good evening once more. So today we have the second class of chemistry, and we are looking at a special topic. We are still doing the introduction, and today we are going to look at what we are calling scientific notation, as you can see on the screen here. Scientific notation. So it's a very simple topic. I'm sure no one is going to be confused. So by introduction, we need to know what really scientific notation is about. Okay, so introduction. Scientific notation, which is, it's also, in case you haven't seen the word scientific notation, it's also called standard form. Standard form. I'm sure you've seen words where they write 2 times 10 to the power 14. Yeah, this is the kind of writing that we are talking about. It is one of the ways, actually the most recommended way we present answers in chemistry. So you need to know how numbers are written in chemistry. So we use this form when you are writing very, this word is actually in bold, very large numbers or very small numbers. So we use this when we are expressing very large numbers. Last time I gave an example of when you are trying to measure the mass of hair or the mass of one single tiny particle of a millimole. They want you to measure the mass in kgs. You're going to find that it's going to be 0.000, about 20 zeros, then you write 1. It doesn't make sense. Your page is going to finish. So there's a better way to write that, and it's called the standard form or scientific notation. So this scientific notation is presented in a special way, which is like this. So this is a general way that I'm writing here. Just change my color. This is a special way that I'm writing here. I mean the general way. So A times 10. There's always 10 to the power n. This is a general way all scientific notations are presented. It's a general way of presenting all scientific notations. So this A satisfies, I'm sure you guys have started learning mathematics, so when I use this language, I expect you guys to understand. A satisfies this set: 1 less or equal to A less than 10. So does anyone understand what this means? Does anyone understand what it means? What this, as in sets? Does anyone know what this means? Nobody? Okay. So what this means is that A is in between, is any number from 1 to 9. Since they're saying A is, 1 is less or equal to. So when they say less or equal to, it means that it's part of the set. So 1 is less or equal to A less than 10. When there is less than, it means that 10 is not part of the set. So this means that A can be any number between 1, 2, 3, 4, 5, 6, 7, 8, 9. So any number, but sometimes it could be 1.1, 1.2. I'm just writing the whole numbers, but any number between this range. Those are the only numbers that are allowed to be written on A, meaning that A cannot be 10, A cannot be 11, A cannot be any number that is above 9. That's what it means. any number below 9 going down, you can write it. Again, it can be less than 1. So you can't write 0.9 as A. Okay, I hope that is clear. Then n, which is this one, n is a member of integers. Do you know what the set of integers is? Anyone with an idea? Okay, this is mathematics. Anybody? Hey, can be talking alone here. Are people there? Guys, give me a sign.
Yes, we are there, sir.
Okay. Is it, are you understanding, or there's a point that you've missed? I can proceed.
No, try to explain more on the same part that you're talking about here.
The part for A.
Yes.
Okay, so we are saying that standard forms have got a special form in which you can express them. That is A times 10. This is 10 to the power n. Now, A and n are just numbers, different numbers. A and n are different numbers. So we are saying that the only numbers that you can put on the part of A are from 1 to 9. This is what it means. 1 is less or equal to A. 1 is less or equal to A less than 10. So this means that A can be any number between 1 and 10, but 10 is not included. So you're saying you can put any number from 1 to 9. So any number above 9 is not acceptable to be put on the part for A when you're trying to express the certain number in standard form. That's what we are saying. So when I'm trying to write a certain number in standard form, you can't put you can't put any number that's greater than 9 on the part for A and any number that's less than 1. So the only numbers that you can put that are allowed on the part for A are these, between 1 and 9. The rest are not allowed. Those are the rules. So I'm trying to give you a general expression for a standard form. Then, I hope that's okay. Is there anyone with a question? So if you still can't understand, I'm going to give you some examples and I'm sure you're going to get it very well. And then, just like on the part for A, n can also be any number, but then we are restricted that n is a member of Z. So the set Z is the set of integers. So integers are whole numbers, negative and positive whole numbers. So meaning that n cannot be 2.1, A cannot be 2.3, it can be 4.7 or any other number. N can only be a whole number. It doesn't matter whether it's 1000, whether it's 200, as long as it's a whole number, it can be the power of 10. It can be negative, it can be positive. That's what we are saying. But on the part for A, we are saying it's just in between. A is always positive. Usually A is positive. But N and A can only lie in this range. But for n, it can be any number, but it cannot have a decimal point. Any whole number, whether negative or positive, as long as it's a whole number. So what we are saying is that, for instance, 2, I think I just like 2 today. 2.4 times 10 to the power 7. So when you look at this 2.4, it's in between the range from 1 to 9. It's in between, because we said A can even be decimal numbers as long as they're in between 1 to 9. That's the rule. Then this 7 that you are seeing here, 7 we are saying is a member of Z. Z is a set of integers, whole numbers, whether negative or positive. So this is an expression of a scientific notation. This means that when you have this is not allowed. So 24 times 10 to the power 18. 24 times 10 to the power 18. What do you think is wrong with this number? Anyone who sees something wrong in this number can just tell us.
Is there where you've put in 24 because it's above 9?
Okay, yes, that's true. Thank you very much. So we are saying the rule is that the part for A, the first part, has to be between 1 to 9. Any number that's above, then you have written your standard form wrongly. For instance, e.g., does anyone know or remember the Avogadro's number? Do you remember the Avogadro's constant? Those that used to like chemistry at high school. Okay. So the Avogadro's number is 6 point, I think should be 6.02 times 10 to the power 23. This is the Avogadro's number. So if they tell you to express this number in a normal way, you are going to find that it's going to cover the whole screen here, just writing zeros and numbers. So they don't want you to do that. They want you to use the standard notation. So the standard notation simplifies things. So this is a very huge, large number, but it just looks simple like that. So according to the rules, we have 6.02. It's in between 1 and 9. This part, remember, we said it's possible, it's okay for it to have decimal point. Then the power for 10, it's 23. It has to be a whole number. So this is okay. This part is okay as well. So this is an example of how you express numbers in standard form. Also, the mass of an electron, if I'm not mistaken, 1.013, something like that, but it's close to that. It might not be exactly like that, but it should be close to that, times 10 to the power negative 31 grams. So now, if they tell you to write this number as a whole, you're going to find that it's going to cover the whole screen. This is in between 1 and 9. This is a whole number. Despite it being negative, we said it can be a negative number as long as it's a whole number. That's what we are saying. This is how you express numbers in scientific notation. So if we have this number, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 200 million. Is it 200 million? Okay, I don't even know the number. It's too big. But the point is, when you have some of you that have got a lot of money, which you can't even count properly in your account. So your account doesn't know scientific notation, so it's just going to bring you very big number. Then in chemistry, they'll tell you to express this number in scientific form. So what you're going to do now is that you follow the rules. You follow the rules. The rules are saying A times 10 power n. They're saying A has to be between 1 to 9. n can be any positive or negative whole number. So this one, 2 is the only number that we're going to put in front. Then the rest, these zeros, you just have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 times 10 to the power 9. This and this are the same, only that this one will make you look educated and as if you know what you're doing. So when you express your answers like this when you're solving your chemistry, I'm sure even tutors will make a mistake. When you're wrong, they even mark you correct. They will just be like, this girl is too neat. I'm sure she's right. So this is the way you present your answers when they ask you to present answers in scientific or standard form. Are we okay? Questions? Is it clear?
Yes, it is clear.
It's clear, sir.
Okay. So now that we have known how to express numbers in standard form, now it's only right that in chemistry there's always calculations. You are not just going to be asked to express a number. What if they tell you to say what is 4 times 10 to the power 7 plus 5.2 times 10 to the power 8? What are you going to do? So normally we are going to express this number back to normal and also express this one back to normal. That's when we add them. So chemistry doesn't want you to do that. Chemistry does not want you to do that. Instead, it wants you to add these numbers as they are in standard form. So now this brings us to our next subtopic, which is addition and subtraction of numbers in standard form. Addition and subtraction in scientific notation. So what they mean here is that how can you add numbers and subtract them when they are written in scientific form without you taking them back to normal, ordinary or village kind of way? They want you to act in a advanced way. How can you do that? So what they're saying is that to add and subtract. So sometimes you find that in an operation there's both addition and subtraction, or you just have to add or just subtract. So this is what you do. When you have two numbers, let's say 3.7 times 10 to the power 9 plus 1.23 times 10 to the power 5. You want to add these two numbers. What are they telling us to do? So they are saying that express these numbers to the same power. They should have the same power. Meaning that what they're saying is that this 5 should become 9, or this 9 should become 5. They're telling us that one of these should change to the other. That's what they're saying. That's the only way you can add or subtract numbers in standard form. How you do that, I'm going to show you in the next second. But the rule is saying if the powers are different, you cannot add or subtract. You can only add or subtract when the powers are the same. So now that begs a question. How do you make powers the same? How do you make powers the same? So I hope you guys have gotten the rule. To subtract or add the number, you have to add, you have to make the powers the same. So 2.43 times 10 to the power 4. How do you change powers? This is what I'm trying to show you. So when you want the power to reduce, if you want the power to reduce, this is what you do. This decimal number, when the decimal number moves to the left, when this decimal number moves to the left, it is going to be 0. Whenever a decimal number moves to the point where there is no number, you just add 0. I know to perform this operation, we are going to break our rules first. We are going to break our rules, but the final answer will get back to the normal rules. So this is going to be 0.243 times 10 to the power 5. So when the decimal point moves to the left, decimal point moves to the left, the power increases. It increases. That's how it goes. So when it moves 2 steps, when it moves pa, then the decimal point will increase by 2 also. So this is going to be 6. When it increases, so this is, you're going to have something like 0.0243 times 10 to the power 6. Okay, I hope you guys are following. When it moves 3 steps, this also increases by 3, but not that it's moving towards the left and not towards the right. That is how you change the power. So we are trying to learn how to change powers of a decimal, of a scientific notation. When a decimal point moves to the left, the power increases. Depending on how many steps the decimal point moves, the power is going to move with respect to the number of steps the decimal point moves. Now, I'm sure you can guess that the opposite is going to happen when the decimal point moves to the right. When the decimal point moves to the right, so let me just write this number again, 2.43 times 10 the power 4. So when the decimal point moves 1 step to the right, then this is going to increase also by 1. It's going to become it's going to reduce by 1. So this is going to become 3. When the decimal point moves 1 step to the right, the power will reduce by 1. When it increases 2 steps to the right, the power will decrease by 2. So
just a moment.
Yes.
I think I've already taken this because I was about to say, like you said, the number on the SI should not be more than 9. So I saw the point to move because it became 24.3.
Okay, yes. So
I think now we're going to.
Okay, I understand your confusion. So when I said that, I said when you're presenting your answer. So right now we are trying to carry out a calculation. So we are trying to add 2 numbers. So we are going to make certain manipulations just for us to add the numbers. But our final answer will still follow the same rules, whereby A has to be between 1 to 9. Then n has to be any number. But at this point, for us to add the numbers, we are going to break that rule. I think I mentioned that. So just for the sake of addition or subtraction, but our final answer will still obey the same rules that we said.
Okay, sir.
All right. Yes. So the number is 2.43 times 10 the power 4. So let's say this moves to the right, which is going to be 24. Yes, we have broken the rule, but we just want to add 10 0.3 times 10 the power 3. This can never be our final answer, but we are just doing this so that we make sure that the powers are the same, because the rule of addition and subtraction is saying that the powers should be the same. So I'm just trying to teach you how to change powers. So when the power reduces, the decimal point moves to the right. When the power increases, the decimal point moves to the left. So decimal point to right, to the right, the power reduces. So when the decimal point moves to the right, the power reduces with respect to how many steps the decimal point has moved. That's what we are saying. So now, if you haven't understood this properly, okay, have you guys understood how the powers increase or reduce? Do we have anyone with a problem?
As for me, I think I've understood everything on how we change the powers.
Okay, Frederick. Anyone?
Understood, sir. Then I wanted to ask, how are we supposed to know, say we're supposed to subtract or we're supposed to add? Or let me say as in, okay, how are we supposed to know as in this point supposed to move left or right?
Okay, I think I'm going to answer that question in our next example. I think it's going to make sense when I do an example. So let me just do the example, then if you want to understand, then you can ask again.
All right, thank you.
All right. So our we have an example now. Oh, where are we? Okay. So you've been asked to add. They'll ask you to add these two numbers, 7.41 times 10 to the power 2 plus 3.26 times 10 to the power 3. 3.26 times 10 to the power 3. Yeah. So they ask you to add these two numbers. Of course, normally as a normal person, you can just take back this number to normal way. I'm sure you guys know how to do that. So this number, first of all, if you want to take it back to normal, this is just 741. Then this is 3260. So depending on how many powers of 10 you have, it means that the decimal point is like that. But we don't want us to use these numbers. No, we don't want us to use these numbers. They want you to use the standard form kind of way. So now, how do you know that the decimal point is going to move to the left or right? If I understood the question properly by Florence, this is what you do. So the rule is saying that to add these two numbers, we need to make the powers the same. This means that 3 either has to become 2 so that the powers are the same, or 2 has to become 3 so that the powers are the same. So you can change either of them. So what you are saying is that when this becomes, so if you want to make this 2 to become 3, if you remember very well, if you want to make this 2 become 3, then the decimal point has to move to the left. That's what we said. So we can either say 0 point, when it moves to the left, 741 times 10 to the power 3. this is the same as this one, only that the decimal point, the power has changed, and this is not the correct way of presenting it. Now, it's very easy at this point to add this number and this number because they have the same power. So we can easily do that. Or if you want, you can make this power 3 become 2 so that it becomes in alignment with this number. So this one can become 32.6 times 10 to the power 2. Remember what we said, when the power decreases, the decimal point will move to the right. When the power increases, the decimal point will move to the left. So now, when you are carrying out this operation of addition or subtraction, you would prefer going for the bigger number. Always choose the bigger number. And the reason I'm going to tell you. So these two numbers, you have 7.41 times 10 to the power 2 plus 3.26 times 10 to the power 3. So let's make 2 have the power of 3, because I told you that you would prefer the bigger number. So we are going to have 0.741 times 10 to the power 3 plus 3.26 times 10 to the power 3. So now, these numbers have got the same power and it's easy to add them. So what you do now here is just to add the A part. This is the A part alone. 0.741 plus 3.26. Even do that times 10 to the power, to the power 3. To the power 3. Yeah, that's what we are saying. So anybody with a calculator, I doubt if you guys have got a calculator, so I guess I'll just do it on my own. Or does anyone have?
It's 4. Yes, we have 4.001
Okay.
times.
Okay.
4.001 times 10 to the power 3.
Okay. 0.01 times 10 to the power 3. Yes, thank you very much. This is our answer. Now, I'll ask you a question. Does this answer fall under our rules for the value of A and the value of N? Does it fall under our rules? Have we obeyed the rule?
Yes, it has obeyed the rules.
Yes. So this is how you do it. Now, the problem with going for the lesser number, you're still going to find the solution, but the problem is going to come in somewhere. So let's say now, instead of converting these two, we convert the 3 to 2. It's going to become like that, right? So we're going to have 7.41 times 10 to the power 2 plus, when we change the power, it reduces, it's going to become 32.6 times 10 to the power 2. These numbers have got the same power, therefore we can go ahead and add or subtract. So of course we just get the A part alone, as long as the moment you see the powers are the same, you forget about the power for some time. So 7.41 plus 32.6 times 10 to the power 2. Okay, That is what we have. Anyone with a calculator to give us the value for this? Anyone with a calculator to give us the value for this number? Right here.
It's given 40.01.
Okay, 40.01 times 10 the power 2. Now, guys, if you look at this number, does it obey our rule? The first rule that we said, does it obey?
No, it doesn't.
It does not. Okay, so we need to make sure that this number obeys the rule. And for us to do that, it means that the decimal point should move at this point. Now, when the decimal point moves to the left, what happens to the power? It increases. So it's going to become 4.001 times 10 the power 3. Okay, so you've seen that now when you go for the lesser number, there's an extra step of changing the decimal point. It's going to shift. But when you go for the bigger number, your answer will just go direct like that. So this is why I preferred you guys go for the bigger number, but they are still going to give you the correct answer. Both of them will give you the correct answer. Is it clear?
Yes, it's clear.
Good.
So now, if you have, in case you find yourself in a situation where you have, let's say this same number, 7.41 times 10 the power, let's say this power changes to 4 plus 3.26 times 10 the power, let's say 3. The rules still applies. This could be plus or minus. The rules still applies. Okay? Only that now at this point, guys, from 3 you need to move like 7 steps. 4 steps to go to 7. Remember, I told you that you choose the greater number. So this will have to, this number, for you to increase from 3 to 7, you need to add 4. So it's going to become 1, 2, 3, 4. So 0, 0, 0. So your number will be 0.00326 times 10 the power 7. You are adding 0.1. So I'm just trying to show you in case the numbers are not different by 1. The previous example that we did, the numbers just followed each other. The powers were 2 and 3. But sometimes you might find that the power are like 5 and 3. So if they are 5 and 3, then you have to move 2 steps. Either you are increasing or decreasing, whatever you choose, it's up to you. But just remember that if you are increasing the number by 2 to suit the powers, then also the decimal point should move in a correct direction by that same number you increased or reduced. Any questions before we move to the multiplication and division part? Any questions on this?
No questions, sir.
Okay, if you are, then everything is clear.
I have a question, sir.
Yes.
So what if it was to be given as in 7.41 multiplied by 10? Then maybe the 7 that is on top has a negative and the other one doesn't have.
Okay.
What can it be?
All right. The power negative 7 plus 3.26 times 10 the power 3. Okay. Who asked the question? Florence.
Yes.
Which one is the bigger number between negative 7 and 3?
It is 3.
3, right? Now, do you agree that you have to move like 10 steps for you to match, to make negative 7 to make negative 7 be 3? Do you agree?
Yes, I agree because
yes, you have to add 10, right?
yes.
So now, if you have to add 10 to this number, where is your decimal point going to move? Left or right? If you're adding, Florence, you've forgotten. Okay, I'll help you. So if you're adding, then always remember that if you're adding to the power, the decimal point moves to the left. It moves to the left. Since I've told you to always be adding, just remember that the decimal point is moving to the left. If it's reducing, the decimal point will move to the right. So it's going to move 10 steps to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all these will have zeros. 0, 0.00000000. Yeah. So your number now will become, how many zeros do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 0.1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, yeah, no. There are 9 in total. 7, 4, 1 times 10 to the power 3 plus 3.26, sorry for the bad handwriting guys, times 10 to the power 3. So this is how you're going to convert it. But of course they won't give you a number as complicated as this. They will give you something that's just basic. But this is the principle. That is how you're supposed to do it. Okay, Florence?
Alright, thank you very much.
Okay, you're welcome. Is there any more questions, or we can move to the last part? Okay, now, okay, so I was actually using space for something else. Florence, all your fault.
No, it's not.
It is. Okay, let me just remove this. Nafanya kuishia. It's okay. Okay, so we now move to the last part. Which is multiplication and addition. Do you guys remember the rules of indices when you are multiplying or adding numbers? Do you remember what do you do to the powers? Anyone who remembers the powers?
What I can remember myself is that when the powers are the same, we just add the when the bases are the same, we just add the powers.
Okay, that's for what? Is that for multiplication or division?
Yes, it is for multiplication. When you are multiplying and the bases are the same, we just add the number.
Okay. Yes. Basically, that is what you're supposed to do. Then for division, you're supposed to subtract the numbers. So this is saying use the law of indices, that is add the powers of 10, since we are saying that the base is always 10. The base is always 10, it does not change. So the moment you hear the word standard notation, they are talking about the base being 10. So add the powers of 10 when multiplying and subtract them when you're dividing. So what they're saying is that when you have 1 times 10 to the power n times 2 times 10 to the power m, this is what you're going to do. 1 times 2. So the a part should multiply the way it is. Or I didn't read the second statement. The a part should be added. I'm really sorry, guys. This should be multiplied or divided. Just take note, this word should be multiplied or divided. I think I was excited when Zambi was playing. That's why I made the mistake. But the a part should be multiplied or added the normal way. So 1 multiplied by 2, which is this number here and that number here, then times 10 the power n plus m. That's what we are saying. That is when you are multiplying. When you are multiplying, that's what they are saying. Now, if you are dividing the same, just the same one, we are going to use the same one. If you are dividing, only that we have a division sign here, division sign, not a multiplication sign. So we are going to say 1 by 2 in a normal way, the a part, times 10 the power n minus m. That's what they're trying to say here. Actually, the multiplication and division part is really simple. Have you guys understood what's happening here?
Yes, sir.
Okay, so that is, so a times 10 to the power n times b times 10 to the power m is equal to a times b, that's what we are saying, times 10 to the power n plus m. That is when you're multiplying. Yeah. On the other hand, when you are dividing, a times 10 to the power n, so a and n are just any numbers. Remember those same numbers, the rules that I gave in the first place. I hope you guys are taking note of this. Divided by b times 10 to the power m. So this is going to be equal to, of course, a divided by b times 10 to the power n minus m. So this is just a simple representation of what these statements were saying. The statements that were just from reading, this is what they were saying. I hope no one has got a problem with that. That is how you carry out your calculations. Okay? E.g., an example now. So let me just give you an example of multiplication. I don't know if it's multiplication. Then I'm going to give you an example which involves I'll just explain. Actually, I want you guys to do it together with another assignment which I'm going to send probably tomorrow. So we have 4, let's say 4.0 times 10 to the power 4 times 1.5 times 10 to the power 2. They want us to carry out these calculations in standard form. So meaning that you don't have to change these to ordinary way. They want you to do that. So we are multiplying. So the rules are saying, let's multiply this number and that number in a normal way. Then let's add the powers. 4 plus 2. That's what we're going to do. So let's go. 4.0 times 1.5 times 10 to the power